This lesson we're going to be looking at rates of change. Now, in previous topics we've looked at as one variable changes in relation to the other, and we've talked about the gradient. And the general form or rule that we used for the gradient was y2 minus y1, so the change in the vertical direction, divided by the change in x, so x2 minus x1. So when we look at the rates of change formula, it's pretty similar. So if we have a function, so let's say f of x, and we want to find out how much does it change between the points A and B. So what is the rate of change between A and B? So the average rate of change will be given by the formula f of at B, so that's your y2 value, minus your f at A, so the y value at point A, and then divided by the change in the x-axis. So that would be B minus A. So that's for the average rate of change, and we've looked at that in previous topics. What we know from using our work with the derivatives is that we can find the gradient at a given point. So we can call that the instantaneous rate of change. So to find the rate of change at a single point, we just find the derivative at a point. So if we want to try and find the instantaneous rate of change of f with respect to x, or f of x at x equals a, then it would just be the derivative at a. Okay, looks nice and straightforward. Let's have a look at an example. So if we scroll this down here, we can see we've got let y equal 35 plus 12x squared, and we want to find the change in y as x changes from 1 to 2, and we want to find the average rate of change over that interval. So we use that first formula that we looked at before. So we had f at the second point, or the function at the second point minus the function at the first point. So first thing we have to do, let's find the value of our original function. So I'm going to let y equal f of x. So at my second point, so let's say at f of 2, I'm going to sub in 2 for x. So I'd have 35 plus 12 times 2 squared. So 12 fours are 48, so 35 plus 48 gives me 83. F at 1 would give me 35 plus 12, which is 47. So my rate of change, or my average rate of change, would be 83 minus 47, all divided by 2 minus 1. So we end up getting 83 minus 47 gives us 36. So that's our average rate of change between the points 1 and 2. Now, for part B, it says find the change in y as x changes from 2 minus h to 2. So now we're trying to find a more general one. And we can see that it looks similar to when we did the differentiation by first principles. So, same process, we've got 2 points, 2 minus h and 2. So we want to find the original function at 2 minus h. And the original function at 2, which we found already, was 83, wasn't it? So we know that from part A, so we don't have to do that working out again. So let's sub in 2 minus h for x. So we had 35 minus 12 lots of 2 minus h squared. So it's a little bit messier than the first one, but we just expand our brackets out here. So we'd have plus, or it should be plus, is it minus or plus? It's plus. So plus, we'd have 12 times, and now we expand these brackets, we'd have 2 squared is 4 times 2 lots of 2 minus 2h, so minus 4h plus h squared. So we end up getting 35 plus 48 minus 48h plus 12h squared. And that would give us 83, the first part, minus 48h plus 12h squared. And to find our rate of change, remember we do the function at the second point minus function at the other point, 2 minus h minus 2. We're going to see that the 2's are going to drop off. Or let's do it the other way. Let's go, that'll be 2 minus h would be this, the first point, wouldn't it? So avoid getting the negatives. Let's put it around the other way. Let's go f at 2. Remember we did y2 minus y1 back in the day. It didn't matter which point was point 1 and which point was point 2, as long as you kept the order consistent between the numerator and denominator. I'm just doing it this way so I can get my 2's to drop off. So 2 minus h would end up getting us average rate of change. So function at 2 was 83 minus 48h plus 12h squared, all divided by 2 minus 2 is 0, minus negative h plus h. So you can see here by doing that, my 83's will drop off, my 2's dropped off already, and I end up getting h down the bottom, so I can cross off 1h there and 1h there. So my final answer would be minus 48 plus 12h for my average rate of change. For the last part, so for part C, let's move it down a little bit so we've got a bit more space. We want to find the rate of change of y with respect to x when x equals 2. So this is our instantaneous rate of change. So we just need to find the derivative at 2. So first thing, let's find the derivative first. So the 35 would drop off. We had plus 12x squared, so that'll become 24x was my derivative. And so therefore the derivative at 2 would be 24 times 2, which equals 48. So if we look at the answer to part B, as we mentioned with the rates of change, if we let, ooh, have I stuffed that up? Yes, I have. Look at that. I was going to say we should get the same answer. So if we let h approach 0, we should get 48, which up here should be positive. So what I've done here, when I've minused that original function, I should have minus brackets around here. So that would become plus 48 minus 12h. That looks better. So if I did the limit of part B, I'd end up getting 48 as well. So if you're really keen on doing first principles, you can do it that way. But if to find the instantaneous rate of change, just do the derivative at a point and you should get the same answer. Okay. Hopefully that wasn't too confusing. We'll look at a few more practical type application questions and I'll make another video for that one. Thank you.